Hey everyone, welcome to the channel. Today we're diving into Microsoft's Phi-3.5-Vision-Instruct, a state-of-the-art multimodal AI model that's designed to handle tasks requiring both textual and visual inputs. This model is part of the Phi-3.5 family and stands out due to its high-quality, reasoning-dense data source from synthetic inputs and filtered public websites. The model is particularly useful for applications involving general image understanding, multiple image comparison, and detailed image analysis. Throughout this video, we'll explore what makes Phi-3.5-Vision-Instruct stand out and how it can be applied to various real-world scenarios. If you found this tutorial helpful, please consider liking and subscribing for more content on AI development and applications. Your support is appreciated. You can get Microsoft Phi-3.5 Vision model from Hugging Face. Now, it's important to note that as of yet, Microsoft hasn't converted this model to Onyx. In this tutorial, we're going to use a Python server and use C# to interact with it. First, let's download the model and then install its dependencies. You can find the list of required packages on the Hugging Face model card. For our setup, we're using an NVIDIA RTX 3090. So let's walk through the installation step by step tailored for that. First thing we need to do is install the latest CUDA drivers. To do that, head over to NVIDIA developer website and follow their instructions for downloading and installing the CUDA toolkit. Once you've done that, the next step is to install the CUDA Deep Neural Network, CUDNN. After installing the CUDNN, you'll need to make sure your environment variables are set correctly. This means adding the paths to both CUDNN and the CUDA toolkit to your system's environment variables so everything runs smoothly. Next, you need to install Anaconda. Anaconda makes it easy to manage different Python versions and environments, which is going to be very helpful here. Once you have Anaconda installed, you can create a new environment for Phi-3.5. Let's call it Phi-3.5, and then install the required Python packages for the Phi-3.5 Vision model. One important note, make sure you install a version of PyTorch that is compiled with CUDA support. To do that, go to pytorch.org, select the version you need, and follow the instructions to install it with CUDA enabled. After that, go ahead and install the other packages listed on the model card for Phi-3.5 Vision. By following these steps, you'll have everything set up and ready to interact with the Phi-3.5 Vision model. Alright, now that we've downloaded the Pi model and installed all the required packages along with the GPU drivers, it's time to test the model. In the Phi-3.5 Vision model folder, you'll find a sample inference Python file. Let's take a quick look at the code. There are several examples to use both text and images. Let's go ahead and execute this sample to see the results. The first couple of prompts are just text-based, and they work as expected. Next, we have some prompts that include images, and they also work without a hitch. The first example is a simple math question, what is 1 plus 1? And we get the correct response. The next example asks the model to write some code, and then we move on to explaining an image. After that, we ask the model to format an image of an Excel sheet, and it does just that. Finally, we provide the model with several images and ask it to explain the content like a slide deck, and it delivers a solid explanation. These examples show just how versatile the Phi-3.5 Vision model is, handling a range of tasks from simple questions to more complex image analysis. Now let's review the Python code that we will use to create the API. We're using Fast API to set up a server that handles chat completion requests, and this server can work with both text and images. We start by initializing the Fast API app with a title, description, and some basic contact info. Then we load the Phi-3.5 Vision model and its processor, making sure everything is set up for GPU usage. The main endpoint is chat completions, where we receive chat completion requests. The request can include both text and images structured in a way that's compatible with OpenAI API format. The code processes user's message and, if there are any images, decode them from base64 and prepare them for inference. Once all the inputs are ready, we use the processor to format them, and then the model generates a response. After generating the response, we calculate some basic token usage statistics and format the output to match the expected response structure. In our case, we're simulating some of these values. At the end, we return the response in a format that includes the generated content, token usage details, and some additional metadata, similar to what you would see in OpenAI's API response. This Python script essentially lets us simulate a chat API that handles both text and image inputs, making it a powerful tool for interactive multi-model conversations. Now let's dive into a real-world example where we use the Microsoft Phi-3.5-Vision-Instruct to extract key information from a receipt and automatically fill out an expense report. What's really exciting about this process is that even if the model misses certain details or we don't get the exact information we need from the initial prompt, we can continue refining our prompt and asking targeted questions to further extract any missed entities. And there you have it, a quick and effective way to automate the extraction of data from receipts using the Microsoft Phi-3.5-Vision-Instruct with just a simple prompt with the ability to fill out an expense report, and the model's ability to handle both text and images makes it an incredible versatile tool. Whether you need to refine your query or extract more details, the Phi-3.5-Vision-Instruct simplifies what could otherwise be a time-consuming task. As always, thank you for watching, and if you found this helpful, don't forget to like, subscribe, and share. Stay tuned for more AI-driven insights.